Just quick, where do we find the hypotenuse?
It's across from the
Yeah, I know it's C, but where do we find it?
It's across from 90 degrees.
Yeah, you look for your 90, wherever that is, and you say, oh, that side is called the what? Hypotenuse. Okay. These two sides, I call them, what do you call them? I call them legs, yeah. I say leg. So you got two legs that make your 90, and one is A and one is B. You want your hypotenuse, just find your right and go straight across. There it is. Okay? You've done this several times. If you didn't, you're going to do it today. Okay? Next slide. Next slide. Okay. Here comes all the big names. And the three big names are, these are the three big ones. Sine, cosine, tangent. Now these are just relationships between sides of a triangle. And when I say sides of a triangle, I mean a right triangle. So let's take a look at this. By the way, this angle, we call it what? What's that funny Greek letter? We call that alpha. We call this one? Beta. We call this one?
Theta.
Theta. We call this one?
Omega.
Omega. Gamma. There's a whole bunch. I don't know. I can't remember all of them. I mean, but
Gamma's a little off.
is gamma? I think gamma. Is this gamma?
No. Gamma's a little
Is
R.
that sigma?
Let me see.
That's sigma.
Gamma's like a little R. It's like a little twig. It's like one.
Okay. Oh, I'll trust you. I'll trust you. Okay. Here we go.
I remember this. This is the only thing I remember
Okay.
from chemistry.
So. Here's the deal. When I say sine of any angle alpha, you're supposed to be thinking opposite over what? Hypotenuse. So if I say alpha, you go to alpha. Don't go to beta. Go to alpha. Opposite is straight across. This one, whatever that number is, and hypotenuse is always going to be where? Where? Across from your right. This is the hypotenuse. Opposite, hypotenuse. So the adjacent side is the leftover. It's where? It's the bottom. Okay. But anyways, opposite hypotenuse, cosine adjacent over what? Hypotenuse. So that would be this bottom over the hypotenuse. And then tangent will be opposite over what? Adjacent. Now guys, I hope you memorized it, but if you did not,
SohCahToa.
yeah, this little acronym will help you. You might want to put it on your paper right now. Okay, SohCahToa just means capital S, means what? Sine is what relationship? Yep, cosine would be adjacent over hypotenuse. Tangent would be opposite over adjacent. That might help you. Put it on your test, put it on your quiz, or memorize it. Okay. Now, you see those over there? That's kind of weird, but they are the reciprocal functions. So sine has a reciprocal function. Its name is cosecant. Cosecant of alpha is just 1 over sine of alpha. But that just means flip the words around. These words get flipped around. Hypotenuse over opposite. Secant is the reciprocal to cosine. Flip them around, hypotenuse over adjacent. And this one's kind of nice. Tangent. Cotangent. They kind of go together, don't they? That's easy to remember. I had a hard time in high school. Believe it or not, I remember high school. Here's the deal. I had a hard time. Sine and cosecant just didn't seem right. Cosine and secant didn't seem right. The names just didn't go together. So how do you remember that? You just memorize it? Is that what you do?
No, it's like, because cosecant goes with sine and cosine goes with secant. So then with secant, it's the co of sine, and cosecant, and for sine, it's the co of secant. So you just realize
You just
that.
have to memorize that it's the opposite.
Yeah.
That's the way I did it. Exactly. In high school, I said C should go with C. It didn't. It went with what?
S.
It went with S. It didn't make sense to me, so I just always remember it's the opposite. So when if I say secant to you, what's the reciprocal function? Yeah, I gotta go back here. Don't go. It should go S to S, but it doesn't. It's weird. But you got to memorize that stuff, okay? Can I move on? Okay. All right, here's your little practice exercise. Fill the blanks in. I'll give you, I don't know, half a minute. Go. Go get the answers. It's just a ratio, guys. It's 2/3 or 6/4, or I didn't even give you numbers, did I?
That's
No.
what confused me.
This is a quiz question, test question. I guess they all are. Okay, it says sine of alpha. Go find alpha. Do not get yourself in the wrong spot. Don't start here. Start here. Okay, start here. Okay. Sine of alpha. I wrote the ratio down, but you really, guys, this is going on in your head, isn't it? You say sine of alpha, you go opposite over hypotenuse. Where's opposite? Where's hypotenuse?
C.
Okay, so basically you should have said what? A over C. Got it. Sine of beta, Zach.
Oh, it's opposite of hypotenuse, so it'd be
B over C.
B over C.
B over C is good. Tangent of beta, Howard.
I put B over A.
Yep. Cosecant. I didn't write the ratio down, but Emma, what is the ratio in words?
Oh, I like the letters.
No, I don't want the answer. I want the words.
Hypotenuse over opposite.
Okay, good, good. She knew this is the reciprocal of sine, so she flipped those two to get this. What's the answer, Emma?
C over A.
C over A. We got it. We're good. We got it. We know what we're doing, right? Oh. Okay. Give me the 6 trig functions of theta. Look at your triangle. There's theta right there. There's theta right there. But there's a problem, isn't there?
We're missing a leg.
You're missing what? The bottom leg. So how are we going to get it? Pythagorean theorem. Go. Go get it. Yes or no? Yeah? I ended up with b squared equals 84. I took the square root. I simplified this to 4 times 21. 4 square root of 4 is 2. Square root of 21, I don't know. I left it. That's it. So this side is what? Right. So, okay. Oh, that helps. Now I can do it. Opposite over hypotenuse. What is it? 4 over 10. But wait a minute. Reduce it. 2/5. Okay. Well, right now, guys, I'm going with the reciprocal function. Cosecant of theta equals.
5.
What?
5.
Okay, so did anybody do this? Oh, it's just the reciprocal. It's 1 over 2/5. Did anybody do that? You can, and then you'll get 5/2. Don't do
That's
this.
too much work.
That is too much work. Don't do that. Just flip it. What is it? 5/2. Okay. All right, guys. I picked on the 2 easy ones because the rest of them all have radicals. Okay, here we go. Cosine goes with secant. Anybody out there want to tell me cosine? Chris? Cosine's what? Yep.
Be around 2 square 21.
2 squared 21 over? 10. Can you reduce it? 2 and 10? There you go. Good? Secant? Molly, what'd you put? You don't know? What should you do though, guys?
Flip it.
Just flip it. Take this and flip it. It'd be 5 over square root of 21. But you don't want to leave radicals on the bottom, so you
It's lame.
rationalize, which means make this number on the bottom a whole number. Just multiply by itself and get what?
5 square 21.
Yeah, 5 square root of 21 over 21. Is this reducible? No. Good?
So you want us to leave it in radical form then and not on decimal?
Oh, no. I don't want decimal.
Okay.
Guess what? This is on the non-calculator.
You're right.
Unless you know what square root of 21 is in your head.
Probably like.
No, you don't. You don't want to try. Next. No, not cotangent. Tangent of theta.
Hey, look at that. It's like 1.6.
Ryan, can you help me?
Yeah, it's 4 over 2 square root of 21, and then that can reduce to 2 over square root of 21.
Okay, wait,
and then,
2 over square root of 21. Gotcha.
and then you do the thing with the radicals where that turns into 21.
The thing, he says the thing, he means rationalize
Yeah.
the denominator. Okay.
Well, we all knew what I was talking about.
And that becomes 21 on the bottom and 2 square root of 21 on the top. Is that good? Okay. Cotangent of theta is, should I flip this, guys?
Not that one.
Not that one.
You should flip that
Oh, actually do this one.
to the middle.
Do this one. If you flip that one, you get what?
Square root of 21 over 2.
Now, guys, if you would have flipped this,
That would have been a
you
little
would have had to rationalize it and get back here anyways, but it's much easier to go backwards a little bit and just look, oh, square root of 21 on the bottom, flip it to the top, flip 2 to the bottom, you're done. Okay. It doesn't matter, you're going to get it anyways, it's just I'm trying to save time for you. Good? Okay. Oh, here they come. They're the what triangles?
Special.
They're special. How special?
So special, they get an entire slide dedicated.
Yes. They're so special that you can do them in your head. Guess what? If you don't have a 40, listen, if you don't have a 40 by 45 or a 30-60, you can't do them in your head. You're stuck. You got to do them with what? Calculator. These are the ones that are on the non-calculator part of your quiz test, okay? All right, so let's talk. This one, actually, this one came from a square like this, okay? And they've made the square 1, 1, 1, 1, and then they did what? Cut it in half. And they said, this is 1 and 1, this is your right. And they did the Pythagorean theorem and found out it's what? Square root of 2. Okay, that's where these numbers came from. But guys, you gotta memorize this. 45 is simply gonna be 1, 1. And the hypotenuse? Okay, memorize. You have it memorized, don't you? From last year? Okay. Next, they came up with this one. Okay? What they did on this one, just so you know, you don't have to know this, but whatever, let's just say we want to. Okay, equilateral triangle, 2, 2, 2, 2, right? Okay, 60 here, 60 here, 60 here, right? You know what they did to it? Cut it in half. They went like this. Right down the middle. Then they only looked at this one, didn't they? Okay, and then they said, don't look here. So here's your 60. What's this one? Cut 60. This is your 30. And then they did this. The hypotenuse is 2. Guess what this side is?
1.
Half of that. 1. And then they did the Pythagorean theorem and got what here? Square root of 3. I'm not sure if you care, but I care. I want to know where these numbers came from. That's where they came from. Okay? Do you ever have to repeat that to me? No. But don't you kind of think it's kind of cool how they did it?
Yep.
No, they didn't do derivatives.
Yeah.
They just cut the 60, 60, 60 triangle in half and then they
I
wrote.
mean, I think it's more.
Okay, derived from. Okay, gotcha.
I mean, I think it's more interesting how Pythagorean theorem came up with. Although my sister also like explained this to me and very hyper and excited about it.
Mhm. Okay, memorize it. Opposite. Well, wait. In a 30, 60, make this number easy. Make it 2. What's opposite of 30? Half of that number. 1. Then what's opposite of 60? Always, always.
Square root of 3.
And you can use the Pythagorean theorem and get all this stuff, but I'm not going to take that time. Okay? But that's your relationship. So now answer these questions up here in the box, which you can't see. Do those. Says these triangles must be memorized, and they should kind of already be memorized from last year, I think. Cosine of 30, tangent of 45, sine of 30, 60, I mean, and sine of pi over 2. Okay, sine of, not sine, cosine of 30 megan is
Square root of 3 over 2.
Megan, did you hear me? Square root of 3 over 2. Okay.
Yeah.
All right. Is she right?
Yeah.
30 adjacent over what? Hypotenuse. She got it right. She got it right. Okay. Tangent of 45. Brandon. Here's 45. What is it? He says 1. Opposite over adjacent. 1 over 1 is 1. Sine of 60. Caleb. Say again? I'll say it again. Oh, square root of 3 over 2. Okay. Okay. Sine of 60. Here's 60. Opposite. Square root of 3 over hypotenuse. Yeah, he got it. And sine of pi over 6 is what, Zoe Johnson? She says 1/2. Did you know? You guys know what this is? Yeah, it's pi is 180 divided by 6. That really says sine of what? 30. You should be looking here. Sine is this over this. Zoe got it right. Good?
Good.
A head shake. Just a shake. Thank you. It's like looking at statues sometimes. You guys would make great statues.
Awesome.
Okay, here we go. What?
Function.
Co-functions. It's like cousins. Cousins. You're related to your cousins, right? Well, these two are related. These two are related, and so are these two. Okay? All right. Sine goes with cosine. Tangent goes with cotangent. Secant goes with cosecant. Okay? The theorem says, you gotta listen. Co-functions of complementary angles. What are complementary angles?
Opposite equal 1.
2 angles
90.
that add up to what?
90.
90 are what? Equal. Or better yet, they're the same. Okay? Let's not even look here. I think that's confusing. I'm going to do this. I'm going to say this. I'm going to pick on sine and cosine. Sine of 30 should equal cosine of y. This plus this equals 90. Should I prove it to you? Yes, I should. 30, 60. What's the relationship? Hypotenuse 2. What's that side? 1. What's this side? Okay, you ready? What's the sine of 30? Look. 1 over what? 1/2. Now what's cosine of 60? Here's 60. Adjacent over. Oh, they are equal. Right? So now we can go back here and go like this. Does this make sense that they're equal? Because why? That plus that makes what? Complementary angles. So it's the same answer. I don't even care what it is. It could be 0.27. The other one's 0.27. They're the same. All right, ready? Hopefully you get this. And, oh, that's weird. Answer that question. That question. Two questions. Write them down. You're not supposed to use your calculator. This is a non-calculator. Not Howard, I'm sorry. Tommy, what's the answer to the first one? 40. He says 40. He says tangent of 50 should equal cotangent of 40. And why? Because they are what? Related, and they add up to what? 90. They will be the same answer. Don't know what the answer is. Don't even care. They're the same. Okay. This cosine of 28 minus sine of 28 equals Zoe. What? She says 0. Is she right? Nobody's agreeing with you, Zoe.
Yeah, I agree.
Oh, Megan does. Megan does. Okay. Here's the deal. Are these two related? Yes. Is this complementary? Yes. I don't care what the answer is, but the answer, they will be what? They will be equal. They will be the same. So this could be a 0.11. So will this. The answer is what? 0. I made that up. Please don't believe me. That's not 0.11. If you want to know what it is, now you can punch it in. Punch it in. What's cosine of 28?
Negative 0.96.
No, it's not negative.
I'm in radians.
Point what? Point what? 9? 88?
0.88.
Guess what? I bet this one's also 0.88, which makes what Zoe said 0. Okay? It does work. It does. You're just supposed to know that, okay? After being told that they're related and they're complementary, they're the same answer. So the one answer minus itself is 0. She got it. Next. Oh, okay. You're supposed to go to page 302, and you must learn these, and that is, look at your trig what?
Oh.
Identities. Okay, let's just talk. It's not hard. You already know some of them. Okay, ready? Here's one. Sine of theta equals what? 1 over what? Cosecant of theta. These are reciprocal functions. So if you know sine of theta, then the reciprocal function would be 1 over cosecant. Okay? If I did it this way, what if I did cosecant of theta? What's cosecant of theta equal? 1 over sine of theta. Okay. There's a whole bunch of these. There's actually 6 of these. If I threw a tangent at you, tangent of theta equals what? 1 over cotangent of theta. But you guys, I hope you know this. If the answer to this problem is 3 over 2, what's the answer over here? 2 over 3. That's what it's really saying. Okay? I don't want to put them all down, guys, because guess what? They're in the front cover of your book. If you actually took your book cover, you opened it up, you're going to see all of these. So I would recommend you know where your front cover is all the time. Okay, after these reciprocal functions comes the quotient theorem, which basically says this: tangent of any angle will always equal, do you guys remember from last year? Sine over cosine, yeah. Please write these down. I'm just trying to get you some basic ones. And then, well, if that's what tangent equals, what does cotangent equal? Yeah, cosine of theta over sine of theta. Okay? These are called the quotient properties. The quotient identity, sorry. Okay? Then there's the Pythagorean identities. You remember those?
Oh, is that the one
Landon
that
says
has
yes.
whatever equals whatever?
It sounds like a Pythagorean theorem. It sounds like this. Something squared plus something squared equals something squared.
Sine squared plus
Sine squared,
cosine squared.
sine of theta squared plus cosine of theta squared equals
One squared.
what?
One squared.
1 squared. Do we put 1 squared? Just put 1. Okay. So anyways, this is known as the Pythagorean identity. Cosine squared plus, sine squared plus cosine squared equals 1. Now, they came up with two more Pythagoreans. Here's where they came from. If you take this, if you divide by sine squared, watch what happens. Sine squared divided by sine squared. 1. Cosine squared divided by sine squared is?
Cotangent.
Ooh, good job. That's cotangent. Because cosine over sine right here is cotangent. Squared stays squared. What about this one?
Cosecant.
Yeah, this goes with cosecant.
Cosecant. Cosecant.
Okay. So this is 1. This is 1. And there's another one. The other one is when they divided by cosine squared, cosine squared, which gets you
Tangent theta squared.
tangent squared here,
Plus 1.
plus 1 equals 1 over cosine squared is?
Secant squared. Like, too far.
Now, you guys, you will, I promise, you will eventually remember all of this. You won't have to open your book and look at them all. You will just start memorizing it, but for the first week, you're going to be really clumsy. You're going to need your book, or you're going to need to write yourself a cheat sheet. You just will, okay? All right, this is the one identity I'd like you to prove to me. I want you to prove that tangent of theta times cosine of theta is really equal to this. So at the very end, I want it to do this. I want this look.
Sine equal sine.
I want this. How does this equal that?
Pardon the interruption for a brief announcement. Students and staff will be parking in the orange section of the parking ramp. Starting on Monday, December 3rd, will be ticketed and towed. Please remember to park in the GSC designated areas, which are maroon. Once again, students and faculty parking in the orange section of the parking ramp. Starting on Monday, December 3rd, will be ticketed and towed. Please remember to park in the GSC designated areas, which are maroon. Thank you very much.
Don't park in what? Orange. Okay, there you go.
Take your name sign off.
Katie, how'd you do it? Okay, how'd you do it? Katie, if your name's Katie,
I did not.
you did not do it. Oh.
Divided by one, just kidding.
Divided by 1?
Divided by
That's
cosine.
what Megan told me.
You know what? I'm going to give everybody a hint. Emma, I'm picking on you though. I'm going to give everybody a hint. Your teacher last year probably said, when stuck, try get everything in sine and cosine. If you want sine and cosine, get rid of that tangent. Tangent is really just what? Look. Yeah, so Emma, I'm sorry, I kind of ruined it for you, but tell me what to do.
So sine of theta over cosine of theta.
So change this to what you just said. She changes tangent to this over this, right? And then you know you're going to multiply this times cosine, right? And then of course, what do we do when we multiply? We don't cross multiply.
No, like across like that.
You cancel
Cross-cancel.
if you can. Is this number and this number the same?
Yes.
Yes. What's left, guys? Sine over 1, which is sine. Sorry, Zach, what?
Never mind, I was looking at sine of theta, cosine of theta.
Yeah, no, I had
Sine
sine.
of theta, cosine of theta, over cosine of theta.
Gotta tell you a secret. When you get back from Christmas break, we're gonna do 5 days of this. You're gonna love when you come back from Christmas break.
No,
This,
see, I
this is
remember.
chapter 5.
I remember last year.
You loved it.
No, when we got to this point, this is when I lost my faith in math
Oh.
because we're no longer using numbers.
No, you loved it. Okay, I quit here last period. Should I quit?
Yes.
You want to get one more done?
Yes.
No, I think this were.
Yes.
You want to quit? You want to get more?
I don't think enough there.
Next semester.
Oh, look at that. There's no bigger calendar. It's 4 point. You're in 4. That was 4.3. Hey guys, do you know